My name is Pierre from Developmentor, and I work with Michael Kennedy, who is going to be in the background and answering your questions. We have posted the link to this, the PowerPoint. So if you want to follow it on a different screen, you can do that. Otherwise, obviously, you can see my screen. So before we get started, I just wanted to share that two things. One is that this webcast is the most popular webcast we have done so far at Developmentor. So we are kind of excited about this. We are kind of excited because it's MongoDB, but it's a semi-surprise because we have had webcasts on different technologies that we thought would be more popular. The second thing is that we run develop.com and Learning Line all on MongoDB. We used to have SQL Server as a database, and we migrated everything to MongoDB, and we love it. We love it for two reasons. Reason number one is that it's really fast. So we used to worry about CPU and scaling and buying bigger servers because we wanted the websites to be very responsive, and we don't really worry about it. So we used to have times where the CPU would be above 50%, and now it doesn't really happen anymore. And the second reason is that this is very, very simple. So talking to SQL Server, even though we used, I think, really good practices, best practices, we use entity framework and so forth. If you want to change things, it's a little bit difficult. With Mongo, it's much, much, much easier. So it allows us to be more responsive. So bottom line is we actually use that stuff ourselves. So we have a pretty ambitious agenda for this 45 minutes to an hour webcast. We'll assume that you know how to program in C#, but you don't know anything about NoSQL or MongoDB. So, and at the end, we want you to be able to actually write a small application in MongoDB. So it won't be the entire MongoDB that you need to know, but you should at least get started. And if you get started, we are pretty confident that you are going to actually like it. So we're going to talk about what NoSQL is and why to choose MongoDB amongst the NoSQL database. Then we'll talk about how to read and write documents using JavaScript from the shell. And the reason is that even though you may do most of your work in C#, in some cases you have to go down and use a shell and modify things or do some queries directly against the database. So you should at least know where it is and kind of how to use it. And then we're going to create a schema in C#, and we're going to read and write Mongo documents using C# and LINQ. Right, so we're going to talk about NoSQL, why Mongo. We'll do an overview of what Mongo is. Let's look at the tools. And then we talk about schema and insertion, deletion, and querying Mongo. So first of all, let's talk about NoSQL, because NoSQL is one of these terms that may seem a little bit vague. And also, if you are coming from SQL, you might be asking yourself, well, why should I use NoSQL? And we have been using SQL databases for quite a while, and usually people are somewhat happy with them. So why should you use something different? And the reason has to do with the type of application that you're going to write. We come from a world where there is one central database, and you have many, many applications accessing this database. So it makes sense to have a database that is very flexible, that you can query in all sorts of ways. And SQL is actually kind of good at that. Right, so you can you decompose your data into multiple tables. You can query tables individually, or you can join them in all kinds of ways. But the one question you need to ask yourself is, well, how easy is it to use? How easy is it to modify my SQL database? And does it really scale if this database is behind a website? Right. So for us, we used to use SQL on our websites, and we noticed that it was kind of hard to scale. So what we had to do is put some kind of caching layer between the website and the database. And that kind of worked, except that it was a little bit difficult to change. Right? And so sometimes the cache was out of date, so we had to worry about all kinds of stuff. And then we go into a new type of application. And the new type of application that we have now is, well, it uses services. Right? The service could be XML web service, could be using SOAP, could be using REST, could be JSON. But in the end, we have these different applications that each owns its database. Right? So if you think about an enterprise kind of system, instead of having one database that has everything, you may have one database that has accounting, another base that has order management, and so forth. And as long as these systems are flexible enough and they expose the right data in the right way to the other services, then everything is good. This allows you to have different types of databases for each service. So there are two consequences. First is the database doesn't have to do as much as it used to. Right? So for example, in this case, the application can take care of security, it can take care of concurrency, it can define the schema, and so forth. And so we enter what we call the polyglot persistence world, where you are going to have different databases, different services, and therefore you don't need to have SQL everywhere. So if you don't need to have SQL everywhere, you can use what we call NoSQL. NoSQL is really just started as a hashtag that people use on Twitter. And like any hashtag, it can mean different things to different people. Right? So NoSQL essentially means that, well, we are not going to use SQL only, so not only SQL. We are not going to have transactions. So I know some of you may be uncomfortable with this, but you can actually do transactions in Mongo, but you have to do it in a different way. You have to essentially do it yourself. We are not going to use SQL as a language, and we are not going to use relationships between tables or entities like we use in the SQL world. So our definition of NoSQL is this. There are two benefits that you're going to get out of this. Number one, it's going to be simpler. And number two, you are going to get better performance. Right? The drawback of using NoSQL is that you are not going to have transactions, you are not going to have joins. But as we will see, the structure of, in our example, Mongo is going to make joins less necessary. And this database has been invented for the age of the web, where we have massive sets of data, so they are going to be cluster friendly, which means that you can have multiple machines hosting your data and scale out. There are actually several types of NoSQL databases. If you go on the Wikipedia page for NoSQL, you will see a very large number of NoSQL databases. There are really four types of NoSQL databases. We are going to focus on document databases, but we also have graph databases, column-oriented databases. Amazon uses that, or key value store databases. The reason we like document databases is that they provide pretty good performance, but also they are very flexible, and they kind of work the way we work. So I'll show you examples in a second. What is central to NoSQL databases is the notion of an aggregate. An aggregate is going to be the blob of data, if you want, that you're going to store and retrieve. In SQL Server, this would be a row, but as we will see in Mongo, it's going to be an entire document, which itself is hierarchical. So this is what a document is going to look like in a MongoDB database. This is not, if you think of documents, you might be thinking, well, is it kind of like a Word document, an Excel document? It's not. And it is a JSON document. So if you have been using any kind of JavaScript recently, then you probably know JSON. What you can see is that we have fields which have a name and a value, and the value can either be an array or it can be another document. So we have something that is inherently hierarchical, and you can put all of your data inside one document. So when we talk about the fact there is no join in MongoDB, well, since you can put everything in one document, maybe you just need to query the entire document and get all the data that you need. It's not going to be always the case that you get everything in one document, but in most cases, it will be the case. So now let's ask ourselves, why should we use MongoDB as opposed to other NoSQL databases? And there are really three main reasons. Well, number one is that this is the most popular NoSQL database. So if you are not sure and you want to go with the crowd, well, this is your database. It leverages standards, JSON in this case, and it's available on pretty much any platform or any language. We are going to use C# because C# is a pretty good language, and it also has a really good driver for MongoDB. But if you're in a company that uses Java or JavaScript or Ruby or whatever, you can use MongoDB. And then we'll talk about performance, right? So let's look at the popularity of MongoDB. We don't really have numbers of how many people actually use it because it's a free database that pretty much anybody can download and install. So there are a lot of people who don't talk to MongoDB Inc., install it silently and use it, and nobody knows about them. However, if you go to Google Trend, and you can try this yourself, go to Google Trend and type MongoDB and the other database, you will notice two things, right? That MongoDB in this case is the blue line. Number one, it's number one, and number two, it's growing, right? So I think we feel pretty good about choosing MongoDB just for this reason. We looked at other databases and we noticed that not many people use them, right? MongoDB is supported by a company which also has tons of money. So it's pretty likely that they're going to be in business for quite a long time. So if you want support from them, this is going to be available. And we know that MongoDB is going to be updated. Reason number two is this is available on pretty much any platform. Again, in this case, we're going to use a C# driver. But if you want to use Ruby, Java, Python, all of these languages, either on Windows, on the Mac, or on Linux, this is possible. Reason number three is performance. So first of all, MongoDB itself is written in C++, which is a good language for doing things fast. MongoDB is a little bit different from SQL Server in the way it uses the RAM. Right, so it's going to use as much memory as possible to optimize performance. But if your machine needs the RAM, then MongoDB will be very polite and give back the RAM. And the way it implements that is using memory map files. Right, so it has a big data file on the disk, and it goes to the operating system and says, please give me a big chunk of memory so I can access these files really, really fast. And the operating system is usually pretty good at optimizing this. Inside these files, we actually have documents, and these documents usually are going to be cached in RAM if they are used frequently, and they're going to be cached in RAM exactly the way they are stored. Right? So it's very easy to go from disk to RAM. And then when you request documents, in most cases, it's going to send you the documents just the way it is. Right, so what MongoDB has to do is just find the document and give it to you. There is minimal transformation that it has to do on the server, which means that it can serve a lot of data and still not use too much CPU. Right? Again, in our case, even when we do lots of queries on MongoDB, we see that the CPU is very, very low. In addition to that, what you can do is distribute your data on multiple machines. This is what we call sharding in MongoDB, or you can look at it as scale out. Right? So you would have some of the data on one machine, some of the data on another machine, and if you can have 2 machines or 20 machines, it scales out pretty well. Each machine, by the way, can also be replicated, so if you have a failure, you don't lose any data. Now let's go into the architecture of MongoDB. Right. There are essentially three things that you need to three concepts that you need to know. Well, it starts with the server, where the server has a series of databases. So far it's kind of like SQL Server, and the database is going to have a series of collections. Right. So you can think of collections kind of like your SQL table. And the reason they are not called tables is that this is not tabular data, this is documents. Each collection is going to have a series of documents, and the document internally is stored as BSON, which is binary JSON. We'll look at this in a second. It's kind of like a row in SQL, except that this is hierarchical, so it can have children. In addition to that, internally, MongoDB uses indexes so that you can access your documents really quickly. The language that you are going to use to access MongoDB is going to be also BSON or JSON. So I will use JSON or BSON pretty much as the same thing from now on. There are technical differences, but you can look at BSON as just being a very efficient JSON. And you're going to send your query, and you're going to get a list of documents, and then you're going to send your documents back to the client. You can do all these queries directly on the database using the command in JSON, or you can use C# on top of this. So we look at how we can use JSON first, and then we look at how we can use C#. So just some more details about BSON, right? The BSON essentially is binary JSON, right? Because JSON is not very efficient for storage. It also has some additional types, right? So we have dates built in, a string obviously, and then we have something called object ID. If you are coming from Windows, this is somewhat equivalent to a GUID. So it's just a unique identifier that is really fast to generate. So now let's go ahead and actually use MongoDB, because I've been talking for like 10 minutes and we need to actually write some code. So the first thing is we need to go to MongoDB and go to download. I'm not going to do it because I already have MongoDB. It's actually pretty fast, right? So in 5 or 10 minutes you should be running. The tools that you're going to find out of the box are not as rich as what you would have with SQL Server. There is a command line tool called, surprisingly enough, Mongo, which is just command line, so it's not as rich as what you would have with SQL Server Manager. But there's another tool which is a different download called RoboMongo, which is actually pretty nice. It's also open source and free, so easy to download. There are other tools. There's something called MongoView, which is kind of like RoboMongo, but personally I like RoboMongo better, so that's what I use. There's also, if you are using .NET, there's something called LINQ, which is not really specific to MongoDB, but if you have a set of classes that expose MongoDB data, you can query them from LINQ. So let me show you just a tool, Mongo, the Mongo shell rapidly, and then we will spend more time on RoboMongo, because I think RoboMongo is just easier to use. So let me go ahead and start Mongo. And that's not what I wanted. Windows 8 is trying to help me, but a little bit too much. Let me go ahead and get it directly. So I've installed, by the way, if you install MongoDB, this is what you will, the files that you are going to see. So mongo.exe is a client to do some queries. MongoD, for daemon, is a service that runs in the background. So I'm going to say click on mongo.exe. And the font is probably a little bit too small, so let me change that real quick. And that should be pretty good. Except it didn't change anything. Properties, no, not default properties. There we go. All right, so the first thing I want to find out is what are my databases. So I'm going to say show databases, DBS, and I can see I have two databases. Let me use the books database. So I can say use books, right? So we said that a database is made of collections. So maybe I want to show the collections. So I say show collections. And I have something called books. So maybe I can say book, and then I can do some interesting things with it, such as find me the books, and maybe I want to have only 5 of them. And have my book is not defined. I say db.book.find.limit 5. I'll explain more about this query in a second. And this allows me to query my books. Right? So DB, by the way, is a database which has a collection, a series of collections. One is the one I'm interested in is books. I find everything. We can filter, obviously, and I want to have only 5 of them. So I get my 5 books over here in JSON, and that's kind of interesting. Now, there's another tool called RoboMongo, which I think is a little bit better. The reason it's a little bit better is that there's a nice GUI, so you can browse your data very nicely. But you also have the entire shell, right? So in this case, let's say I want to find books. Right, here it is. I can say find. And if I have too many, like this is the case right now, it will page nicely, so I can see the first 50 books and the next 50 books and so forth. What is also nice with RoboMongo is that you can actually edit these documents. Right, so if I want to edit this one over here, I go and say edit, and I have some JSON. I want to change the ISBN number, put something else, and validate, and this is okay. And let's go ahead. Oh, I said view. That's not what I wanted. If you say view, it's read only. I want to say edit. Let me change the ISBN number to something else, and then save it. And there it is. It's going to be saved. All right, so this is RoboMongo. Again, on the left, you have your server, which has a list of databases. You can browse your collections, and then you can see each document inside your collection. Very cool tool. So we're going to now insert data inside Mongo and retrieve data using the RoboMongo. And there are many commands you can use, but I'm just going to show you the ones that are important. The first one that you need to do is use is how to find stuff, right? So the find command is what you need to do. So you specify your database, the name of your collection, and you say find, and then you can specify some parameters to filter things. You can also sort your documents, and you can also do some limit, which will be the equivalent to the top in SQL. When you use operators, it's going to get a little bit more complicated, so I'll give you some details on this. And then you can also insert some data, right, by using insert and then save. Now, I have a bunch of data over here, but maybe I don't want to start with existing data. So I'm going to drop everything, and so I don't have any data, I don't have any car makers, I have nothing. So this is the fresh server that you would have if you start from scratch, right? So let's first of all create a database. Oops. Let's go ahead and create a database. All right. Let's say we're going to have a database for people. So I'm going to call that people database, people DB. The people database is now empty, so I'm going to create a collection. So select the collection, create a new collection. Let's say we're going to have people. And the people collection is empty. Right, so if I double click on it, there's nothing. If I call find, there's nothing. So let me go and insert myself inside these people. So I'm going to say insert, and then inside as a parameter, I'm going to have a JSON object. I can type whatever I want. So I'm going to say name, colon, Pierre. Right, so if you're used to C#, you will want to put an equal sign over here, but this is JSON, so it has to be colon. And then I will say, let's say the city I live in, city, colon, San Francisco. And I'm going to insert myself. And what you will see is that obviously now I can see the document I just inserted. But there is one additional attribute or field that has been added, which is the ID attribute, ID element. Every document in MongoDB needs to have this ID. You can provide your own if you want, but if you don't, MongoDB will create one for you. And this is where it uses the object ID, creates essentially like a random number if you want. It's actually not completely random. It's based on the process that you are using and the timestamp and some other things, but it creates this object ID for you. Now, if I want to add another person, I will say insert. So Michael is also on the line, so we say Michael, name equals Michael, or colon Michael. And then I will say city, where he lives in Portland, so let's do Portland. Now, what I can also do, because this is Mongo, there's no schema that I have to respect, so I can add some other stuff. Right? So I could say, well, in addition to his age, sorry, his name and city, I could have his, well, let's say I'm interested in medical data. I'm going to say blood type, and with his blood type, and let's say is AB. And then if I'm interested in let's say sending him some stuff, I'm going to say credit card number equals, and then I can put some data over here. Maybe Michael is going to give us his credit card number, right? So what we have here is this idea that there is no schema in MongoDB, which means that you can insert anything you want, which is both a good thing and a bad thing. It's very good because you can add some any kind of data you want. So in this case, there are probably multiple ways to look at a person, and I have this in just one document. If you're in SQL, you would have to have multiple tables, or maybe you would have a table with a gigantic number of columns, which wouldn't be practical. In this case, I can look at one person, have different types of information associated with this person, all in one document. What we can also do is, so I showed you that we can edit the document. Let me go ahead and do this for me. I can also have properties that are either arrays or sub-documents. So for example, let's say I want to talk about my hobbies. All right, so maybe I'll have an array of strings. So let's say I like to cook, right? So cooking, and maybe I like to go hiking or kite surfing. Right. Now I save that, and it looks like it's, it's pretty easy. But something really nice happened, which is that I didn't have to create another table. Right. If I were in SQL, I would have to create a hobbies table and have some kind of key associated with this and so forth. It would be kind of difficult to manage. I don't have to do this. Maybe I want to have also sub-documents. Right, so maybe I want to talk about my street address. I can put that inside a document. So I can say street, about address, and let's put a document inside of this. All right, so I would say street, colon, 1, 2, 3, whatever. All right, then I would put the zip code, and I put an integer 94133, and then I put a state. Let's say California. So obviously this is not great data, but as I save this, I have a problem, and the problem is it's probably invalid. Invalid JSON. I forgot to put a comma. All right, save it. All right, perfect. So and my address is over here in my document. If I have multiple address, a shipping address, and a shipping address and a billing address, sorry, I was spacing out, then you would have these two documents inside the main person document. Okay, so we talked about how we can how we can insert things. Now let me go ahead and find things. So let's say I want to find a document where the name is, let's say, me. Well, I'm going to put inside this find parameters. I'm going to try to, there we go, make things a bit bigger. I'm going to say name and then colon and then what name I'm looking for. Here, there we go. And let's go ahead and send that. And I will see only one document because there's one only one document that verifies this query. What I can also do is find everybody, let's say, but order by. So I will say sort, and then specify the field I want to sort with. So I will say name. Well, I don't really have a value over here, so I'm going to say 1, which means sort ascending. And if it was -1, it would be sort descending. Well, I made a little bit of a small mistake over here because I forgot to put this as one JSON object. So let me put braces around it, and now it should work. So we can see Michael first, and then me. And if we say -1, then obviously it's going to be the opposite. That's me first. Okay, one other thing I wanted to show you is how we can use operators. So let's say that everybody has an age. So let me go ahead and edit this document. All right, so Michael is, let's say, 35. And let's go and save that. And I made one more mistake because I forgot. What did I forget? I don't need this last one. Okay, and then let's edit the other one. That's Michael, and let's put myself. Okay, and my age is 21. Most people don't know that. I had to double that, but I'm actually 21. There we go. I made a mistake. I put one too many commas. There we go. So now I can say, if I want to say, give me everybody who is, let's say, more than 35 or more than, let's say, 30 years old. Well, if I say age colon 30, it will give me everybody who is actually 30. So this is where things get a little bit more complicated because I have to say everybody is greater than 30. That's the way I would like to say it, but this is not valid JSON. So instead you create an object, then you specify the operator. In this case, it's going to be greater than, and then the value is going to be 30. Well, this is fine, except that greater than is not recognized. You have to put a funny character in front of that. It's going to be a $sign. Right? So this looks a little bit ugly. We're going to get rid of that when we do C#, but this tells me that I want to get everybody who's more than 30. Let's go and try this. And I have a problem because I forgot to put curly braces again. And let's do that again. And if I run it, I have one more problem because I can't type. This is a colon. And now we have everybody who is more than 30. If I want to have everybody that's less than 30, then it's going to be LT instead, and that's me. Right, so what you can see here is that we don't use SQL at all. We just send queries using JSON to Mongo. So now we're going to talk about how to use all of this from C#, right? Because this is all cool, but I think this was a little bit difficult. Now, what we said is that MongoDB does not have a schema. It does not have an explicit schema, but we are going to expose our MongoDB data through some kind of service. And let's assume this service is going to be written in C#. Well, the C# service can enforce an implicit schema. And the way you're going to describe a schema is very simple. You're going to define a set of classes, and as long as you access all your data through these classes, the schema will be enforced. Actually, before we, yes, I was going to say, yes, I was going to say, are there any questions? Yes. Well, I haven't written C# yet, so maybe I should write C# first, and then that will answer the question, maybe? Oh, how do I create the connection? Okay, so in RoboMongo, when let's say I don't have any connection, right, I'm going to delete everything. So I'm going to say disconnect. So I'm starting from nothing. When I click over here, let's say file, connect, this gives me my local database, and I've saved that, but I can say, let me create a new one. And then you can specify what the name of connection doesn't matter. What is the address of the machine? So localhost is my local machine, obviously, but you could use a different different machine, and then you can have authentication and advanced options. What is the default database? Right, and then you say connect, and then you get access to this is your server. Any other question, Michael? Okay, I guess yes. Oh, that I like this question. Any sizing issue? I guess Mongo was really designed so that you can store a a lot of data, right? So essentially, as long as your disk is big enough, Mongo is going to be your tool. Now, it's possible that if you go, so first of all, this kind of the size that Mongo really addresses is, I think if you have less than 1 terabytes, this is considered not so big, right? If you have less than 1 gigabyte, this is, I don't know, what's the right word? Minuscule. So anything below 1 gigabyte is really like very, very small. Between 1 gigabyte and 1 terabyte, it's okay. And then 1 terabyte and more, it starts being serious. So as long as your disk is big enough, you're fine. It's going to store BSON, which is somewhat efficient for storage. So I think that should be fine. I'm not sure if I answered the question. Did you want to add something, Michael? Yeah. Oh, yeah. Right. Oh, and by the way, this, okay, 2 more questions, yes? Sure. Yeah, we'll talk about this. Yeah. Yes. Okay. So we'll talk about this later. Yeah. Yeah, that's related to the first one. Yeah. Okay. Yeah, so the design of your index, by the way, that's a great question. And that's probably the key performance issue that you're going to have with Mongo, which is which index should I use? And obviously, if you don't have an index, it's probably bad. If you have too many indexes, it may also be bad. So the more indexes you have, the more the performance is going to suffer. So designing your index in the right way is really key to performance. There is a limit of 64 indexes per collection. So that gives you an idea of the kind of number you should have. Usually we have something like, I don't know, like 3 or 5 indexes per collection. What we have found so far is that inserting the speed was actually very, very good, even with multiple indexes. But obviously, the more you have, the more the insert performance is going to go down. One thing you can consider is if you are bulk loading your data, you may consider removing your indexes, inserting a whole bunch of data, and then creating your indexes so that it's a little bit faster. Okay, any other question, Michael? Well, if maybe he's talking about charting, where you can distribute your data. Okay, well, why don't you clarify this and then let's move on the other ones, okay? Okay, so now we're going to dive into C#, right? So this is going to be maybe more familiar with you. So you can use Mongo any way you want, right? The way you write your C# code, obviously Mongo doesn't know anything about this, but usually there are a few things that kind of make sense. The first one is you should have one type of document per collection, right? So in this case, we have 3 collection: author, book, and user. Well, it makes sense not to put all that stuff in one collection, even though you could. I think it's better to have them in separate collection. And there is a one-to-one mapping between classes and collection. Now, you can also support inheritance. So you could have descendants of books if you wanted to inside the book collection. But the main point is one class, one collection. There is support out of the box for obviously serializing all the properties that are public and read and write. And if you have arrays or list of dictionaries, this also works out of the box. There, as we saw, every document has an ID property, so you must have an ID property defined in your root class. So let me go ahead. Yes, question? Right. So yeah. So I guess the answer, we're not going to cover this in the webcast, but the answer is yes. And there are 2 things you can do. You can do replicas, where you have the same data on multiple servers, or you can do sharding, where you are going to distribute your data on different servers. Right. So and you can use both of them together. So in this case, you could have your data replicated in multiple data centers, so it's a little bit faster to access from different regions. But you can also, do sharding to do scale out. Okay, so let's go ahead and actually write some C# code, because I've been talking for like 40 minutes without running code, so obviously I'm not getting nervous. Okay, so let me go ahead and start Visual Studio from scratch. And I'm going to show you how we can get the libraries for Mongo and how to define the schema, and then we're going to insert data and we're going to query data. And you're going to see that this is pure goodness, because it uses LINQ heavily. So if you know LINQ, querying data in Mongo is going to be pretty easy. I'm going to use a console application. Let's say we're going to have some books, so I'm going to say book app. Right, so far there's nothing that is really special about my app. It's really like a blank app. Not sure why Visual Studio is thinking so much. Anyway, here it is. So now that we have the main program, I'm going to add a reference. Well, I may or may not have the Mongo client installed, so let me go ahead and use NuGet for that. So it's that simple. I say I want to go online. I want to use anything that has Mongo. And probably the best one that comes is going to be the one I want. And there it is, the official MongoDB C# driver. Let's go and install that stuff. Of course, there's some kind of license, but I'm fine with it. And it downloads it, and it's going to give me 2 DLLs. Right? The first DLL is going to be MongoDB.BSON, which is a low-level DLL that deals with how, what is a BSON document, how to serialize, and so forth. And then we have the driver, which has the higher level thing. Now I'm going to have a book, and let's say the book, so there it is, here's my class, public class book, and class has 2 S's, I think. There we go. Let's say we're going to have a property called, let's say a book has a title, and let's say that the book has an ISBN number, and let's say the book has a publisher. Right, so far this book has nothing really specific about it. Now, if I want this to be stored inside Mongo, I need to have an object ID. And there are really 2 cases. Either you know of a unique key for your type, In this case, maybe the ISBN number would actually do. If you had a person, maybe a social security would do, or maybe you don't. And if you don't, you just create a property of type object ID, so you don't have to worry about generating this thing, and then you call it ID. You can call it underscore ID or ID without underscore uppercase. MongoDB is going to treat that as the ID column field. So now that I have my book, let me make sure, let me go back to MongoDB and destroy everything I have. All right, so I don't want to have a books collections. Let me delete this database. There we go. And the people database, sorry, Michael, I'm going to drop both of us. There we go. And yeah, that's tough. So right now, this is completely empty. I'm not going to actually create the database. I'm not going to create the collection. The way MongoDB is going to work is if it's not there, it would be nice enough to create it for you. So what do I need to do to go to MongoDB? Well, first of all, I need to have some kind of client. So we say Mongo client, and that's part of MongoDB. Awesome. That's my client equals new client. In this case, I'm going to connect to the local database, sorry, local server on with a default port, so I don't have to do anything. But if you wanted to connect to another server, then you would have a connection string with some parameters, server name, the port, and so forth. Then once you have a client, well, I want to get the server for it. That's my server. And then once you have the server, you want to have a database. So I'm going to say var db equals server dot get me a database. It's going to have some books. So I'm going to say books. Maybe it's going to be a library, or maybe it's going to be a bookstore. There you go. Bookstore is good. And then I'm going to have a collection. So I'm going to say db dot get collection. And there are two ways to access collections, either in a typed way or in an untyped way. In this case, I want to do it in a typed way, so I want to have a collection of books, and the name of the collection of books is going to be book. And then I want to say db, so that's going to be a collection, var collection equals, and then I say collection dot, and then maybe I want to create a new book. So I'm going to say save, and I'm going to put a book inside of it. So for the book, let's create a local variable. Let's initialize it, new book, and book.title equals, what's a good book? How about MongoDB for dummies? Or actually no, not for dummies, for C# developers. Yes? Can you? Yeah, you know what? Let me add it later. But that's a great suggestion. Maybe we could have a price. Book count, page count is what you wanted? Yeah. Okay, so the ISBN number obviously is this, as you know. And then the publisher is whatever. It's going to be, let's say it's going to be developmental. And we have created our first MongoDB app. Now we're going to actually try it. What do you think, Michael? Do you think it's going to work? Yeah, let me just reformat the code so that it works pretty good. Okay, cool. So I'm going to start it. All right, it runs, comes back, didn't crash. That's good. And let's make sure it's inside the database. So we didn't create the database, but if I refresh, you'd see that the database has been created for me, and the collection has been created, and the book is there. You know, for people who are used to SQL, it's kind of surprising that it actually works the first time, right? And here it is. Let me do just a quick demo of inserting multiple books. Now, as you can see, this is a lot of code, right? And maybe what I want to do is encapsulate this inside some kind of class. So what I would say is I have a class. I'm going to call that book, let's say context. You can give it any name you want. And all of this stuff is going to be inside a constructor. Right, so maybe we'll say this. We are going to keep the database. This.database equals that. And then it's kind of a good idea to expose all your collections as properties. So we'd say a Mongo collection of books. Let's call that books. get, and let's return db.get collection of book, and it's called book. So this kind of simplifies my coding because I can put this in a different file. Right? So basically, I've moved my code for initializing everything inside a context. So if you're used to entity framework, this is kind of the same. So now I'm going to say books context equals new book context, and then I'm going to do the same thing. Let me do this one here. Context.books.save, and I have my book. Let me have the volume 2, and let's go ahead and run this thing. And there it is, and it actually works. Let's refresh, and let's take questions. View documents, and here's my second book. Awesome. Questions, Michael? Okay, would it be possible to make the SBN the primary key? Well, and the answer is yes. Well, let me go and do it. The answer is yes, and what I'm going to do is just have an attribute that says BSON ID, SON ID, it is, and it will treat this as my ID. Now, one thing to know about this is that it's actually not necessarily what you think it's going to be, because if I say, let's remove everything from here, remove all documents, and remove all documents, awesome. Refresh, it's not there. Where do I do refresh? There we go. So it's not there. If I insert the document, then what's going to happen is it's going to use the ISBN as the ID, and but there won't be an ISBN property or an ISBN field in Mongo. Right. So it's just a trick that the C# driver uses to use your a property as the ID. Yeah, so I changed the schema. So it's a great question. So what if I want to add something? And you add a request for a new field, didn't you? Go ahead. Okay, so page count. Yeah. So if it's a page count, then there was a question also about nullable versus non-nullable. Well, one way to do nullable is to mark it as nullable in C#. Right? So I say page count. Right? And the way the C# driver is going to work is if you define properties that are not in the MongoDB document, we don't really care about that. So they are going to have the default value. In this case, it's nullable, so it's going to be null. So if I say context.books, we haven't talked about how to query this, so let me go and do it right now. You say as queryable, and then you can pass any kind of query. Well, in this case, I want to have all of them, so I don't really care. Let me get the first. Oops. Let me get the first book. And so it's going to be a book. Okay, strongly type, awesome. Obviously, if I let me say book number 2. I'll say book. Book. If I look at the page count, in this case, it's going to be null. And what we have in MongoDB is something that doesn't have a page count at all. If you want, you can also say, oh, by the way, if this thing is null, don't store it at all. So, well, actually, let me do this first. So let me go and save this document, this book. So first of all, this is null. I didn't show you. I may show you for sure. And then, yeah, I didn't save that. I'm going to do that in a second. I want to show that the page count is null. And then I'm going to resave my document. So I'm going to say context.books.save book. It's so easy and fast. I feel like I want to do it. There we go. If I go over here, what's going to happen is it say, well, you specified something that was null, so I'm going to store it for you. All right, so I'm going to say, look at my book over here, and it has a page count which is null. Well, that's text actually space. So what I can say is BSON ignore if null, and if my page count is null, it's not going to even appear in the database. Right, it saves a bit of space. And let's go and view documents. And my first document doesn't have a doesn't have a page count. Question, Michael? I'm sorry, I didn't get that. Where is the server? Where is the server instance initialized? Oh yeah, so I didn't set the database connection at all because this is default. This is a server, and it has it uses default port. If I wanted to, I could say, well, I want to. Well, let's do it specifically. So I'm going to say I need to pass some variables over here. So I would say settings. So let's create the settings. And the settings is going to be a new instance of this thing called settings, which has a, so the name of the server is going to be, how do we call that, host. Okay, settings dot, whatever it is. It's one of these things. I think it's not right there. Server, there we go. Dot host equals, let's say, localhost. And then I'm going to use a different port. Well, actually, I can't do that, so it's read only thing. So dot server equals new, and then I say localhost. So obviously, you would put your server name over here, and then there's the port number. I think by default it's 2017. Yeah, there you go. That would actually work as well. Okay, so that's probably something you want to do over here. And if you add security, if you want to pass your credentials, things like that, that's also the way you want to do this. Okay, questions? Okay, so I have a small demo that I feel like I have to do. Right? I have a bunch of books, and I want to load them in MongoDB, and so I have some code for that. Okay, so I have a CSV file with a bunch of books, so I can open it in Excel if you want. Nothing really exciting. Except Excel is getting really slow for some reason. I guess it's a really big file, right? I have like 200,000 books, and I have an ISBN number and an author and a title. So let's go ahead and have a little bit of code for getting that data just extracted. So let me copy this over here. And let's put it in my main program. There we go. All right, so what I'm going to do is say, well, that's good, get that stuff. Okay, I'm going to say, let's go ahead and save a bunch of books. So let's not do that. So let's have a loop. So for each var item in get book data. All right, so this gives me just a bunch of strings. Let me create a book. Var book equals new book. Then I'm going to say book dot ISBN equals item 0. Book dot with the title equals item 1. And then I have a book dot publisher. It's actually the author, but that's fine. Item 2. And we probably want to replace stuff like quotes with nothing, and do it for the other one as well. And then once we are done with this, so once we have created the book, we just say save. It just goes to the database and saves it. And then we're going to get only, let's say, 20,000 because we are kind of late. And let's go and run this. Okay. So 1, 2. I got something wrong because yes. Oh, I already did that. Okay. Yeah, I do a skip over here. That's not very smart. Yeah, thank you for catching that. So Michael is paying attention. Awesome. So 20,000. Go and try this. Restart. Okay, 1, 2, and I do it again because somebody is looking at it. That's because I have it open in Excel. Okay, there's a bit of drama. Will this demo actually work? Okay, 1, 2, 3. Okay, it's done, and I have all my data now in my books. Okay, the reason I want to do this is I want to be able to have data. So I have all my books over here. There we go. Yes, questions? Well, go ahead with the question. Yes. Can we use different port? Yes, we can. Right, so you just put in a different number. Can you do it after you create a connection? And I guess the answer is, well, just create a new connection. Right. So in this context, you probably would want to have another constructor that passes the port number. Yeah. Okay, so now that we have all this data, well, it's time to actually query the data. So let me go back to my context. So I can say context.books. I already showed that to you. There's something called as queryable, and this is awesome because now I can pass LINQ queries, right? So I can say give me all the books dot where books goes to b dot page count is let's say greater than 5, right? And then that's going to give me a set of books. Okay, so we can actually run that. This is not going to be so great because we don't have any. Well, how about we say console write line books dot count and then console read. All right, so this just says 0, and of course we're going to change it. And there it is, 0. So we're going to look at one of these guys and say page count is more than 0. So let's go ahead and edit this. Page count. I'm not sure how I spelled it. This is case sensitive, so I have to make sure it's the same spelling. Capital P, yeah, that's what I thought. So page count equals, let's say 200 pages, and let's go ahead and save. And let's go ahead and try again. And that should give us one book with more than, I think we said more than 100 pages. There we go, more than 5 pages. So this is a really simple query, but because we have documents, so I'm going to skip this because we have done this. This is because we have sub-documents, we can do some interesting things, right? So obviously the first query, give me the book for a particular ISBN, our price is less than that, less than a certain number. You can order, you can select to get any particular fields, you can do a select with a date, you can do regular expression, so give me all the books that starts with an A. But if you have books that have authors and the authors in particular states, you can say things like give me all the books that have been authored by somebody who's in the West Coast, so somebody who has a state that's either California, Oregon, Washington. Or give me, if the books have tags, give me all the children book, right? So where the tags contain something like children. And if a book has a review, you can say, or a set of reviews, give me all the books that have any review, give me all the books that have any review that is coming from me, or any review, give me all the books that have been reviewed only by me. So this, the ability to create a document and the sub-document is really, really powerful. In this particular case, because I've written this app from scratch, I didn't create an index. It should be somewhat slow. But once you create an index, all these queries are going to fly. Do you have any question, Michael? Okay. Well, I think we should wrap up because it's an hour. I just wanted to say one more thing about how to update documents. So I showed you how to save. You either say save or update is essentially the same. You can also remove documents. That's pretty obvious. You can retrieve documents and then save them, but you can also have the an atomic update, right? So what happens is you can say update, and you specify all the objects that you want to update and the update that you want to do. So in this particular case, I say give me all the books that have been published before yesterday, and set the is on sale field to true. So this has two benefits. First of all, this is atomic on the document. And second is you don't actually have to retrieve all these books and then change them and send them back to the server. It's all server side. There's some additional info on that, and you can do some magic to make this really easy. So what do we talk about? First of all, before we go into summary, any pending question, Michael? Right. So one thing we haven't covered is what happens if you have multiple documents and these documents have if you have multiple collections and you want to have references. And we don't have the notion of foreign key in Mongo, and one of the reasons is that we want to be able to scale really well. But what you could do is you could say, well, I'm going to have another collection. So let's say we create a collection for authors, right? And the author would have some kind of ID, right? So maybe the ID would be just an object ID, or maybe I would have like a social security or something like that. Well, let's say Michael is going to be an author. So I'm going to say book.insert. I'm going to say name equals Michael. And I'm not going to specify anything else. I think that's going to be enough. I need to have all the parentheses right. So there we go. So if I do this, it's going to insert a new, okay, and I can't type because I'm used to C#, that's a colon. All right. So I now have a document inside this new collection with a very weird object ID, but I can use this object ID. So let me go ahead and use that. So I'm going to copy and paste this object ID over here. And let's put it inside a book. So if I use the first book, let me go ahead and edit this one. What I could do is say, comma, author ID, and then just paste what I've done. Right? So it's not it's not enforced by Mongo that this object ID actually exists, but this allows you to have the equivalent of foreign keys in SQL. Now, if you want to do a query and query both the books and the author, you will have to do two queries. First, retrieve the author, and then all the books for from this author, for example, or vice versa. So two queries, no joins in this case. Any other questions, Michael? Yeah, so you don't have joins. As you can see, because we have this idea of being able to embed documents inside documents, these hierarchical documents, the number of collections you're going to have is going to be much smaller than what you would have in SQL. So I think in our case for Michael, I don't know if you remember the number of tables we had and how many we had in Mongo, but I would say maybe like divided by like 4 would be a reasonable number. So maybe like 4 times fewer collections than you have tables, which means that you don't have to do joins for a lot of your queries. But if you have to, then you do 2 queries, one on collection and the other one on the other collection. All right, any other question? Michael? Yes, okay. Can I convince you that without joins, it scales better? Well, I'm not sure I understand the question, because joins are a problem for scaling. Oh, I see. So the fact that instead of doing one query, you have to do 2 queries. Right. Yeah, I think you kind of answered it. I guess the other answer is if you try it, you're going to find that it's usually much faster than in SQL Server. It doesn't mean that SQL Server is either a bad product or, but it's just so much easier to scale really well on MongoDB. Yeah, so just as a, because you know, a lot of people have asked about this, you know, join multiple collection kind of thing. Let me show you if I have an author, how I get all the books for these authors. So I've created a new class called author, and this is obviously a collection of authors. And now if I say I have an author, and let's get all the books for this author, I would do it this way. I would say, if I can write, okay, so you don't need this. So I would say, first of all, let me get the author. Context.author. In this case, I have a new one, so I say first. It's easy. And I need to make this enumerable as queryable, sorry. And then I would say, give me all the books for this author. So I would say books equals context.books dot where B goes to as queryable. B goes to B dot is it author ID equals author dot ID. Of course, I didn't create this property, so let's go and do it real quick. It's an object ID. Awesome, thank you. And I need to like put a semicolon or something. There we go. All right. So as what Michael was saying is that this is one query, right? So we send this to the server. We just get one query. So if you have like 1,000 books, just one query to get the books. It is true that you have two queries, one for the author, one for the books, but I think two is not so bad. And because the queries themselves are so fast, I think you're going to do pretty well. Any other question, Michael? Oh, okay, well. Yeah, okay, let's do that. Yes. Well, let's do a summary and then let's do the resources. So, well, the summary is going to be pretty short, right? Mongo is awesome. It's really fast, scales really well. And as you can see, it works really well with C# because you define all your schema in C#, and then Mongo is going to be happy with pretty much whatever you give it to him. The fact that you can use LINQ is pure joy, right? So you can query with LINQ, you can insert with LINQ, you can delete with LINQ, everything is LINQ based. So this is actually, surprisingly, because Mongo is very Linux centric, but it works really well with C#. And then I showed you how we can update stuff.